Assalamu alaikum. Hello, everyone. This is February-March 2019, variant 2. Question 2. A 3.7 gram sample of copper 2 carbonate is added to 25 centimeter cube of 2 mole decimeter cube -3 hydrochloric acid. Which volume of gas is produced under room conditions? So to calculate this, actually we need to do the chemical equation firstly. It should be balanced. So this is copper carbonate CuCO3 plus 2HCl to produce CuCl2 plus carbon dioxide gas plus water. Here, guys, we need to focus actually on carbon dioxide. Let's make it blue. So carbon dioxide is the product we need to calculate its volume. We need the volume of carbon dioxide. So here, stoichiometry, this is 1, and the ratio for hydrochloric acid is 2, and copper carbonate is 1. So first of all, we need to calculate the number of moles of HCl, because here in the question for HCl, here we have the volume of HCl, and also we have the concentration. And as you know, to calculate number of moles, so N equals CV. So number of moles of HCl equals to, this is given, times 25, actually this is centimeter cube, so must be divided 1000 to be decimeter cube. Okay, so number of moles of HCl equals finally 0.05 mole. Okay, this is for HCl. And then we need to calculate number of moles of copper carbonate. Here, guys, we have the mass of copper carbonate 3.7, and also we can calculate the MR, the molecular mass, MR for copper carbonate. So number of moles of this equals 3.7, which is a given mass, divided MR. So the total is going to be 0.03. So this is number of moles of copper carbonate. Actually, guys, let's come back to the stoichiometry. Here this is 1 to 2. So it means here we need, regarding to this again, so actually we have this 0.05 is called the limiting reactant. This one is limiting reactant. Okay, so because CuCO3 is half of this, so if you use 0.05 divided 2, it's going to be 0.025. So this is actually number of moles needed of copper carbonate to react with hydrochloric acid. And if we come back again, guys, to the number of moles we calculated for copper carbonate from the mass given, which is 3.37, I think. No, 3.7 only. So this is 3.7 grams. So this mass we converted to be moles. So this is 0.03 moles of copper carbonate. So remember, guys, this number of moles, only 0.025 will react and 0.005 will be excess. So excess will not react. So actually, guys, only 0.025 will react because HCl is the limiting reactant. It controls the amounts of the reactants. So only 0.025 will be taken from 0.03. Okay, so now we can calculate regarding to again the stoichiometry. So because the stoichiometry here for copper carbonate is 1, and regarding to this carbon dioxide is 1. So if we say 0.025 of copper carbonate reacts, so also 0.025 moles of carbon dioxide gas is going to be produced. So this is number of moles of produced carbon dioxide gas. You know, guys, we have another rule or relation, N equals V. This is for volume over 24. This is how we calculate. This is for carbon dioxide gas. And actually we have now number of moles, and we have, this is 24, so we can calculate volume of produced carbon dioxide gas. So volume equals N times 24. Number of moles is 0.025 times 24 equals 0.60 decimeter cube. So if we come back to the question, you will find 0.025 60 is going to be letter A. Okay? Number 3, which statement about a 3p orbital is correct? You know, guys, 3p orbital. You know, we have the principal quantum number, which is n equals 3. And then this n actually have 3 subshells, which is 3s and 3p, and we have 3d. And for 3p actually, guys, it contains 3 orbitals. We have px, we have by, and we have pz. So remember, guys, here 3p, this is the subshell, and orbital means one orbital of this. It could be px, py, or pz. And you know, guys, every orbital is filled by only 2 electrons. So here we have actually 2 electrons for every one up and one down, as you know. Okay? So let's come back. Which statement about a 3p orbital? So we talk about orbital of 3p. So it could be this one, or this one, or this one, any one of them. It can hold a maximum of 6 electrons. So I think it's not 6 electrons. We said the maximum is 2 for every orbital. It can hold a maximum of 2 electrons, not 6. So this choice is wrong. It has the highest energy of the orbitals with principal quantum number 3. Actually, no, because it doesn't have the highest energy of the principal quantum number 3, because we said we have 3D. 3D is higher than 3p. So this is also wrong. And it's at a higher energy level than a 3s orbital, but has the same shape. Actually, guys, same shape is completely wrong, because, you know, S, the 3s, actually, all S, they have spherical shapes. And, you know, P, they have dumbbell shape. So the correct answer must be D. It's occupied by 1 electron in an isolated phosphorus atom. If we actually, guys, distribute the phosphorus atom, you know, P, you can get P1531. This is from the periodic table. So this is phosphorus, this is P, as you see here. So you see, guys, this is 15 protons, which equals 15 electrons. So you can distribute 1s notation. So 1s2, 2s2, 2p6, 3s2, and 3p3. And now let's derive these 3 orbitals for 3p3. It means we have 3px, it contains 1 electron, 3py, 1 electron, 3pz, 1 electron. So if we choose any orbital of them, any one contains actually 1 electron. So that's why the last one is okay. It's occupied by 1 electron in an isolated phosphorus atom. Okay? Number 4, the 8 species that follow all have covalent bonds. In which pair do the species have different shapes from each other? Now we talk about the shapes of molecules. This is the geometry of molecules. The first one is PeCl2. You know, guys, Pe in the periodic table, you can find this is beryllium. You will find 2 electrons because this is group 2. You will find 2 electrons outside. So Cl2, you know, every Cl atom has 7 electrons in the outermost shell. So this Cl has 7. So I'm going to do X. And then, you know, 1, 2, 3, 4, 5, 6. And here is for the other Cl. Is going to be, here is also 1. And then 2, 3, 4, 5, 6, 7. So the shape, as you see, guys, for this is the bond between dot and X, dot and X. So the shape is going to be linear. So this bond is linear. What about CO2? You know, guys, for CO2, this is carbon, C. It has 1, 2, 3, 4 in the outermost. Remember, we draw only the outermost electrons, not all electrons. So because carbon is 6 atomic number, so the first one will take 2, second shell will take 4. And for oxygen, you know, every oxygen atom has 2 electrons in the outermost. Not 2, actually they have 6, but only 2 will make the bond. So here we have O, 1, 2, and then we can continue 3, 4, 5, 6. And this is the same 1, 2, 3, 4, 5, 6. So actually we have double covalent between carbon and oxygen, and here is also the same shape. This is called linear shape. So this bond here actually, guys, is linear. So it doesn't matter this is double bond or single bond, but the shape is linear, and you know the angle in this case in both of them is going to be 180. The angle is going to be 180 in both of them, so they are the same. Second one here, CH4, this is methane, and NH4. Actually, guys, CH4 and NH4, they will be also the same, because carbon, you know, has 4 electrons in the outermost, so it can make 4 bonds with hydrogen, 1, 2, 3, 4 with hydrogen. What about NH4? You know, NH3, the normal ammonia is NH3 like this, 1, 2, 3, and this is, you know, 4 means we have coordinate bond. So here we have another H if we continue this. So check, guys, we will have the same number of bonds. And also remember here N and C, they are in the center, no lone pair. So all angles will be the same, and every angle equals 109.5. So all angles here 109.5. This is the same also here, 109.5. What about the shape? This shape in both of them is called tetrahedral. It's called tetrahedral. And remember, this is when the central atom here is surrounded by 4 bonds and no lone pairs. Remember, no lone pairs, so the angle will be, all angles will be 109.5. So this is not correct. This is also not correct. Let's check the third one. Here, guys, we have NH3 and PF3. In NH3, we said this is N, and we have 1, 2, 3. Okay? Actually, here we have 1 lone pair in case of ammonia. We have 1 lone pair. So, actually, guys, this shape is called trigonal pyramidal. Trigonal pyramidal, and here angles, all angles now will be, this angle was going to be 107. So this angle 107, it's less than 109.5, because you know the issue of lone pair will repel with other bond pairs, so the shape is going to be different from in case of ammonia. What about BF3, guys? Here BF3, you know, boron is in group 3, so P is surrounded by 3 electrons in the outermost shell. So we have 1, 2, 3, and then we can draw also 3 Fs. So this is F1, and this is F, and here is F. So actually, guys, if you check the bond now, sorry, this is the bond here. So actually, if you check, the bond is going to be also trigonal as this, but as you see, guys, this is trigonal. It's called the trigonal planar. All of them lie in the same plane, so it's called trigonal planar. And remember, P here is the central atom, and it doesn't have any lone pair. It has only, we said, 3 electrons in the outermost. So all angles will be equal. Every one equals 120 degrees, because you know sum of all angles around a fixed point is 360. So every one is going to be 120. Okay, guys, so I think it's very clear this is the correct answer, because they don't have the same shape. This one is called trigonal pyramidal. The value of the angle is 107, and here we have, this is called trigonal planar, and the value of the angle is 120. Actually, guys, the last one here, SCl2 and H2O. You remember O and S, they are in the same group of the periodic table. If you check here in the periodic table, you can find O, this is O, and this is S. So they have 6 electrons in the outermost. So actually, they will make the same shape exactly like water molecule here, the shape of water molecule, and the angle is 104.5. Here is the angle is 104.5 in case of water and SCl2. Okay. Number 5, this is histidine is an amino acid. This is the shape of histidine. What are the approximate bond angles 1, 2, and 3? So if we check 1, so I think we can make sure that C carbon atom here, guys, is the central atom. It's surrounded by 1, 2, 3. No lone pair actually in case of carbon. So because no lone pair, so we can take the same case like this. So it's going to be trigonal planar, and every angle is going to be 120, exact like this. So actually, guys, it's a rule. You can use it all the time. So 1 must be here 120. So we need to cancel A. A is not correct, and it should be one of these B, C, or D because 120. If we check the second one, number 2, here is the same case, N in the center and surrounded by 3. But take care, guys, this is not 120 because N atom has lone pair. Remember, N atom is surrounded by 5 electrons, the outermost. Remember N, very important to remember N. And here is 1, 2, 3. So all of them are 5. So it can make 3 bonds and still has here lone pair. So because of this lone pair, so the value of the angle will be less than 120. We said in case of ammonia, it's going to be 107. So this angle must be 107. So here we need to cancel this choice because this is 107 and this is also wrong, so it should be letter B. So actually B is the correct answer. And for the last one, let's check. Here we have carbon, and carbon is surrounded by, this is the central atom, and here is 1, 2, 3, 4. This is the same case as methane. So remember in methane we said 109.5. So this is exactly as methane and as this is NH4, okay? Actually, you can check better drawing here. This is, here NH3, and we said this is called trigonal pyramidal, and the angle is 107 here. And here this is called trigonal planar, angle is 120. And this is actually, guys, C. 1C is the central. It's surrounded by 1, 2, 3. So the angle is going to be 120 also because no lone pairs. For this C, actually, guys, you see 1, 2, 3, 4, surrounded by 4, no lone pair. So all angles are going to be 109.5. Actually, guys, again, this is a rule. So once you have this and you don't have any lone pairs, so remember this directly. Okay. Next one. This is May, June 2019. This is variant 1. Sample of element X is analyzed using mass spectrometry. The mass spectrum obtained is shown, as you see. What is the relative atomic mass of this sample of element X? Actually, guys, the question of relative atomic mass is really important. And also, it's very easy to do. We need to take the abundance ratio and say times here the mass. Okay, so we'll take this times, and then we say plus the percentage times also the mass times, and then we say plus, and then the percentage here also times 115, and everything should be divided 100. So I think we can do this. It's very clear. 3 times 1, 1, 2 plus blah, blah, blah. So divided 100, and finally we have 115.35, and because we have only one decimal place, so 5 will be 4. So if you check, you will find this is 114.4. This is the last one. So guys, please take care of the relative atomic mass. It's very important question usually in exams. Number 3, a washing powder contains sodium hydrogen carbonate NaH3O3 as one of the ingredients. In a titration, a solution containing 1 gram of this washing powder requires 7.15 centimeter cube of 0.1 mole decimeter cube -3 sulfuric acid. For complete reaction, the sodium hydrogen carbonate is the only ingredient that reacts with the acid. What is the percentage by mass? So we need percentage by mass, guys. This is percentage by mass of sodium hydrogen carbonate in the washing powder. Guys, to calculate this, we need to use this relation. I think everyone knows. So here we need to use the mass of NaHCO3 over the mass of the washing powder, okay, and everything times 100 to get the ratio, okay? So we need actually the mass of NaHCO3 and the mass of the washing powder. Actually, guys, we need to make also the balanced chemical equation first of all. So this is NaHCO3, sodium hydrogen carbonate plus sulfuric acid to produce Na2SO4 plus carbon dioxide plus water. And here is this is 2 and 2 to balance the equation to make sure everything is okay. And then because we talk about sulfuric acid and sodium hydrogen carbonate, so the stoichiometry, as you see, the ratios between them is 2 to 1. So here we have 2 to 1. So actually, guys, number of moles of H2SO4, we can use the given. So here, guys, check. You're going to find here, this is 7.15 centimeter cube. This is 0.100. This is a concentration of sulfuric acid. We can multiply them together to know number of moles. So number of moles 0.100 or 0.1 times 7.15 over 1,000. Remember, we say over 1,000 to change from centimeter cube into decimeter cube. So number of moles is going to be 0.000715. Okay, this is for sulfuric acid. And because sodium hydrogen carbonate is double, because this is 2, so we should multiply this number of moles times 2 to know number of moles of sodium hydrogen carbonate. So after multiplying through, this is number of moles of the sodium hydrogen carbonate. Okay. Also, we need to calculate MR of NaHCO3. So MR means Na is 23. Also, you can get all of this from the periodic table. 23 plus 1 for hydrogen plus 12 for carbon plus 48 O16 times 3. And finally, it's 84 grams. This is the MR of NaHCO3. Okay. So let's come back. Now we have the MR. Again, this is MR. And here we have N. This is number of moles. So, guys, we can say N equals, this relation, N equals M mass over MR. So we have N and we have MR, so we can calculate the mass of the sample. So the mass of NaHCO3 equals N times MR, so equals 0.00143 times 84. So the mass of the sample, the mass of the NaHCO3 is going to be 0.12012. This is the mass in grams. And finally, we can use the relation we stated here, percentage mass equals mass of NaHCO3 over washing powder times 100. So the mass we calculated, actually, as you see here, this is the relation. So the mass we got 0.12012. This is divided 1 because it's mentioned in the question. Actually, the mass of the whole sample is 1 gram. Look at this. This is the mass of washing powder. So times 100, so it's going to be 12.012. So if we take only one decimal place, so it's going to be 12.0. So the correct answer here, guys, is 12.0. This is number or letter C. Okay. Number 4, the outermost electron in an atom of neon occupies a particular orbital. Neon, guys, Ne, in the periodic table, you will find this is 1020. So, which shows the relative energy and shape of this orbital. First of all, guys, we need to distribute also neon to know everything about it. So this is neon 1020, 1s2, 2s2, and then 2p6. So the outermost shell here, guys, actually it's P, and because it's P, so P has dumbbell shape, and so first of all we should choose dumbbell shape, so it could be either this or this, so it means this is wrong and this is wrong. Let's check here. So energy of orbital relative to other occupied orbitals, higher or equal, and here lower or equal. So actually, guys, it must be higher or equal, because it can't be lower, because this is the outermost shell, so it's higher or equal. Lower means this is inner shells, not outermost shells. So actually the correct answer is E. Then here we have in which species is there a lone pair of electrons. This question also is really important, guys, to take care. So CH3, so you know carbon atom has 4 electrons the outermost. So 1, 2, 3 with H's. And here we have a single electron. So actually this is not lone pair, this is single electron. So this is not correct, this is wrong. What about the second one? CH3 plus, plus means this is C also, 1, 2, 3, okay, with H's. And here plus means this single electron is lost. Yeah, this single electron is lost, so we can add here plus. So this is electron deficiency. So this is called carbocation, so this is not lone pair. So this is also wrong. Letter C, we have CH3 minus, so C 1, 2, 3 minus. And this minus here refers to we have actually lone pair. So this is lone pair minus, and this is the correct answer. And for the last one, actually, guys, this is wrong also because CH4 means 1, 2, 3, 4. So no lone pair, all electrons are busy with bonds with H's, so this is not correct also. Okay? Next one. This is a major 2019 variant 2. The first 8 successive ionization energies for 2 elements of period 3, take care, period 3 of the periodic table are shown in the graphs. This is the value of ionization energy. This is the electron removed, and here is the same. Let's check the first one, guys. Let's count number of electrons removed. So this is 1, 2, 3, 4, 5, 6, 7. And you see, guys, between this 7th electron and the next electron, we have a dramatic gap. Look at this dramatic gap between them. So it means actually this is an energy shell and this is another energy shell. So this is a shell and this is a different shell. So once we have a big gap like this, so it means we have 2 different shells. So this is outermost shells contain 7 electrons. So 7 electrons, so it must be in group 7 in the periodic table or group 17. So this is actually, guys, if you skip the transition metal in the center, so it's going, this is group 7 or 17 here, guys. Look at this. So we have one element of this actually. So we have here chlorine and we have here bromine. S is wrong as SE is wrong, so it could be one of them, A or B. Let's check the second graph here. So here we have 1 electron removed and this second electron removed. And you see also, guys, look at the gap here, the big gap between 2 electrons and other electrons. So actually it means the outermost shell here contains 2 electrons only. So 2 electrons only means this is an element of group 2. So element of group 2, so it must be one of these elements. And here we have Mg and Ca, so it could be Mg and Ca, both of them are correct. But if you check here, he said in period 3. So in period 3 means we have Mg already in period 3 and calcium in period 4. So actually the correct answer is Mg. Okay, guys, this is the correct answer. Number 4, a sigma bond is made between 2 carbon atoms in a molecule of ethene. So ethene, guys, you know we have C, double bond C, and we have hydrogen. We studied this in our level also. So this is H, 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 H. So which diagram showed the orbital overlap that occurs to form this bond? So first of all, guys, this is carbon atom with carbon atom. And he said sigma bond. So because sigma bond actually, you know, this is straight bond or head to head, not sideways. So we need to skip this. This is wrong because this is, as you see, guys, this is sideways. So this is wrong. We can't take this. So we need to choose one of them. So before doing this, we need to actually distribute carbon atom. So carbon, 612. So 1s2, 2s2, and then 2p2 because they are 6. So we have the outermost shell is 2p2. And also we can make the same for the other carbon because we have 2 carbons. So every one ends by 2p6, and this is also end by 2p6. If we check A, actually this is S bond S. So this is wrong. Second one, spherical means S and dumbbell means P. So this is also wrong because here B and P. So actually the correct answer is C because this is P, sigma bond with P. So this is sigma with P. So this is the correct answer. Okay, guys. Number 5, the table shows some properties of 4 substances. Which substance could be potassium iodide? Guys, potassium is a metal. This is in group 1. And iodine actually in group 7. And this is also non-metal. Guys, the behavior of metal to lose electrons, so to form potassium K+, and the behavior for iodide, because it's non-metal, is to gain 1 electron to form I-, and the compound produced from this is going to be Ki, which is ionic compound. So ionic compound, from the properties of ionic compound, so actually the melting point is high. So actually negative is not correct. Negative is low. Here we have 2 values could be correct, 680 and 1600. Which one is correct? Let's check second property. Electrical conductivity when molten. If we have potassium iodide molten, guys, ionic compounds, if they are molten or aqueous, so they can connect electricity or conduct electricity. So they are good conductors of electricity. So actually choice C is going to be correct, and D also is wrong because it's wrong. Okay, guys, hopefully you find this is helpful. Thank you so much, guys. See you.